Okay, today we're going to graph the 6 trigonometric functions. So because you have a unit circle quiz mañana, tomorrow, might as well talk about this all, and since it is about the unit circle, let's think about this point right here. What would you label that point? Okay, better get that one straight. Okay, x, y, 1, 0. Okay, and then up here, and over here, and here. Okay, need to know those. Those are key. So what you're going to need is I want you to calculate key points, max, min, x-intercepts over the interval 0 to 2 pi for the functions in parts A and B below, and graph them over this interval. All right, I'm going to graph the sine of x over this entire thing. But first, I'm going to graph it from 0 to 0 degrees to 360 or 2 pi. Okay, we're graphing in radians. See it? It's all labeled, the x-axis is labeled in radians. Okay, and you remember that our points are written cosine theta, sine theta. Okay, so that's important. So let's think about where the sine wave will begin. So I'm going to say if x is 0 degrees, what is the sine of 0? Well, look right here. The sine of 0 is, guys, you better know, the second part of the point is the sine, so it's 0. I heard some of you saying it, but I saw some other faces that didn't seem to be sure. Okay, so the sine at 0 is 0. All right, now, next you note that pi over 2 is labeled on here. Okay, well, what about pi over 4? That would be right between there. It's right smack in the middle of that quadrant, right? Pi over 4. You should know that that's the square root of 2 over 2. Square root of 2 over 2. Let's see. In quadrant 1, from 0 to pi over 2. That's the length of the quadrant 1, or how far it is through quadrant 1. Is the sign positive or negative? It's all positive. So I'm going to expect this graph to go up. Okay? So at pi over 4, if you did sine the square root of 2 over 2, which, well, that's the sine, square root of 2 over 2, you could type on your calculator sine of 45, and you would find you're going to get 0.70 something. All right? Now, I don't really care that much about that one, but I guess it's kind of giving you a hint about what's going on. This is 5, or 0.567, so it's right around there. It's coming up. And then what happens at pi over 2? The sine is, okay, sine is the second part. Sine is y. So at pi over 2, the sine is 1. You better know how to use this unit circle. All right, that's the point. It is the point, pi over 2, comma 1. You're going to be labeling these points. This one is at 0, 0. I'm not going to label the pi over 4. I'm going to show you which ones I need you to have labeled. Okay, so the we're going to have 5 key points over this interval. Now, let's go over to pi. What's the sign at pi? 0. So y value. What's the sign at 3 pi over 2? The sign is negative 1. Okay, what is the sign back at 2 pi? 0. Okay, we just completed one sine wave because we went all the way around the unit circle. And what would happen next is it would repeat again. All right, so let's sketch it. So what I'm trying to get at is, notice that all of these were positive values for the sine. So the sine wave goes up, it reaches a maximum of 1, and then it comes back down. And it is a curve. You have to make sure you are not making lines, segments. They have to be curves. Okay, then it came and down under, and so this was all of this part. You see that that was the first quadrant. This was the second quadrant values. Okay, and now we're going into the third, which is going to be underneath. So that's why it comes down. We just graph from there to there. okay? And now we're still underneath, but we're coming back up to 0. Now you don't have to shade all this in. I just did it for a pretty effect right now. Okay, because those aren't part of the graph, all right? I just wanted you to see that the circle relates to where it is. So this is a quarter of it. That's a quarter. The next quarter is here. The next quarter is underneath. And the final quarter is there. All right, so that's the sine wave. I'm not going to shade them every time. Okay, so now that we have the sine graphed, we could continue it on. So what would it be at 5 pi over 2, do you think? Where would we go to if we're going to repeat this pattern? We'd come up to 1. So every pi over 2, we would have a new point. Now let me show you which ones you need to have labeled. Now I'm going to go backwards too, so this would not be at positive 1, it would be at negative 1. Okay, now the ones you need to have labeled are the ones I started off where all the shading is. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. Those are the 5 points that have to get labeled within one cycle of the sine wave. So when we start doing more stuff to them, where we start stretching them vertically and compressing or stretching them horizontally, or compressing them vertically, okay, all different things we're going to do to the graphs, and we're also going to shift them, okay? And we'll learn how to label all of these points. That's our first graph. No, it is not on the quiz tomorrow. That's why I'm doing it today, but I did not do the lesson the day before the quiz. So I'm just teaching you how to graph, starting the graphing, that's all. Next week, we're going to start doing all different things with these graphs. We'll start looking at variations of them. Just looking at the basic trigonometric functions. So no, it's not. Graphing we will have a whole graphing quiz after we learn more about graphing. Okay, so if I just go ahead and make a unit circle here. Again, I'm just putting those points on here, and let's think about cosine next. So we got 1, 0. You need to know those, of course, for your quiz tomorrow. 0, 1, negative 1, 0, and 0, negative 1. Okay, you know where we are, pi over 2, etc. So, yes. It's not going to be on your quiz tomorrow. Okay. Unit circle. Yes. Yes, you do. You need to know, you need to be able to write for me that all of the trig functions. I'll let you write all in quadrant 1, but the rest you have to write them all out. Okay? Yes. That little part at the top. Okay, so let's just quick figure out what this graph's going to look like. What is the cosine at 0? 1. So it starts here. That's the point 0, 1. What's the cosine at pi over 2? 0. What is the cosine at pi? Negative 1. So it's down here. And at cosine at 3 pi over 2 is back to 0. And then at pi over pi, it's 1. So the cosine wave is very similar to the sine wave, but notice that in quadrant 1, cosine is positive. So we're positive, but then what happens? Cosine is negative. I'm not going to shade all that. In quadrants 2 and 3. Okay, and then in quadrant 4, it's positive again. There's your cosine graph. That is a graph. Oh, and by the way, what was the period of this function? What was the period in which it's not, where you get one full cycle? How far did it take to go around the circle? 2 pi. 2 pi. There's your interval. Okay, so you want to know the period of the sine wave is 2 pi. You must know that. What is the period of the cosine? It's also 2 pi. Okay, so then if I decided I wanted to extend this, then I would just come back to 0 on the right. I don't know why I made that red. I just did. I'll make it green. And over here, it would come back to there. So that would just be extending it the full length of the graph. So what you always want to do when you're graphing these, graph one cycle, and then if you have to extend it beyond that, then you just continue it. Okay, so it follows the pattern. What I need to have labeled, though, are the 5 key points within the 0 to 2 pi. So this is 0, 1. This would be pi over 2, 0. This one is pi negative 1. This one is 3 pi over 2, 0. And the last one is 2 pi 1. Okay, and yes, those are going to need to be labeled on all of your graphs. Okay, let's check out the tangent. So what I thought would be, again, I'll just quick make a little unit circle. Not making it that big this time. The same points I'm going to be looking at, but I might look at more. I got 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then in between there, I might like to look at halfway between at pi over 4, which is the square root of 2 over 2, square root of 2 over 2. And any more of those, which would, of course, be halfway into those quadrants. All right, so now I'm going to think about what would the tangent maybe look like. Now, the tangent is y over x, right? Oh, I don't know why I wrote that goofy like that. The tangent's y over x. So we're going to be looking at the points as y and look at them as y over x to determine the tangent. So that's how you can get the tangent off of the unit circle. What is the tangent at 0 degrees? Well, it's y over x, so it'd be 0 over 1, which is 0. So it crosses at 0. Then let's go up to pi over 2. The tangent would be y over x, 1 over 0, which is undefined. What do you get when you have something undefined for a value of x? What do you think it would make? Our whole, or what else did we put in places that were undefined? We did our rational functions, guys. What did we put in where x could not equal? A dotted line, which is called a asymptote. Asymptote, all right? You need an asymptote there. All right, so since it's undefined at pi over 2, we're going to draw in a vertical asymptote. This has vertical asymptotes because it has places it's undefined. All right, now let's go over to pi. The tangent would be 0 over negative 1. 0. Okay, so far I've just got these 2 points, and I've got an asymptote. Then I come down to 3 pi over 2, or 270, and I do y over x, and that's undefined again. So I got to put in another asymptote. Where do you think there's another asymptote? Yep, negative pi over 2. And then there's another one I could fit on here at negative 3 pi over 2. Okay, I still haven't even gotten one cycle of this guy yet. I've got a point here, so it's doing something in this area. All right, so let's think about what would happen at pi over 4. Pi over 4 would be y over x, which would be the same thing over the same thing, which is 1. I'm going to make this be 1. Unlike it was a half on the other graph, I'd like to make that be 1, please. All right, and because I just don't want this thing to look weird, so this is going to make it look better. And down here, negative 1. Okay, so like if I went, let's see, if I got quadrant 1 is from 0 to pi over 2, I'm at positive. So that means this thing is doing something, and it's coming through here, and it's running up along its asymptote, because we know our graphs run along our asymptotes, right? Okay, now let's check out what happens in, wait a minute, what about quadrant 4? Is tangent positive or negative? Well, one of these would be negative, so it would be negative 1. You follow me? Right. So that means back here at negative pi over 4, we're at negative 1. So I'm going to make a point there. All right, so what that tells me is that this thing came along the asymptote, came up here to 0, 0, made a twist, and went back up the other side. That's one cycle. Okay, then if you went past pi over 2, is the tangent positive or negative? All students, it's negative in quadrant 2. So it must be coming from down here. And then in quadrant 3, all students take, tangent is positive, so it's coming up. All right, guess what? The tangent does not have a period of 2 pi. How many times has this repeated already? Well, and that happened from pi over 2 to 3 pi over 2, which is 1 pi over 2, 2 pi over 2. 2 pi over 2 is pi units. Notice this is broken up in pi over 2s, and one whole cycle is happening in 2 pi over 2, which is pi. The period is pi for the tangent. Why is that? Well, the tangent is positive in quadrant 1, it's negative in quadrant 2, it's positive in quadrant 3, and it's negative in quadrant 4, so it's repeating itself sooner than 2 pi. Okay? Repeating itself. All right, so anyway, what we could do to extend this, this would just be another chunk that ends at 2 pi. And then if we went back this way, this would be coming up that way, and it would be, our twist would be here, and it'll come back down along there. Now you would have graphed every bit over that interval given. Okay, now I'm going to check out I think we're doing the cosecant next. Nope, secant. Okay, now, what is this the reciprocal of? Oops, reciprocal of the cosine of x. We already graphed the cosine of x. Since it's the reciprocal of the cosine of x, I'm going to use the cosine graph to help me guide me through this one. What I say, if you're going to draw this one, the way to learn it right now and get the idea of where it came from, or you'll put it into your brain, hopefully, is quick, my cosine graph, it started at 1, and I'm going to dash this, guys. So, and then it went to 0, then it went to -1, back to 0, up to 1. Okay, so I'm just going to make a little tiny dashed cosine graph. And I'm going to use it as a guide. Okay. Now, the secant is the reciprocal of the cosine. So there are going to be places where it's undefined again. How come? And that's because the cosine is 0 some places. If the cosine is 0 some places and you flip a 0 over, you're going to have 0 on the bottom now, which is undefined. So anywhere the cosine is 0, there will be an asymptote. So you can find your asymptotes by using this graph right here. So we're going to go bing, bing, bing. We've got an asymptote at pi over 2. We have an asymptote at 3 pi over 2. Now, this cosine, and this was the next one, right? I don't know why I felt like I was going to be doing the, yeah, I'm doing it right. I just kind of bugged me. I just thought I was doing the sine first, the one with the reciprocal of the sine. All right, anyway, in quadrant 1, cosine is positive, so would the secant would be also positive. But it's the reciprocal of this. So since this is coming from 1 and going down, it's going to do the opposite. So if I flip this over, it would go up along the asymptote. And in here, I have a little smiley face. So the secant is going to do the opposite of smile. It's going to frown. So it's going to go upside down. You'll still have the point pi, -1 on there. Did I remember to plot my, oh, I didn't label points on the tangent. That's okay. I did label them both on sine and cosine though, right? Okay. All right, and then here, since you got a upward trend here, this would be the flip over of that, so it's going to go like this. That is the graph of the secant in one interval. Now, what is the period then of the secant? It is 2 pi. Okay, it's 2 pi just like the cosine because it's the reciprocal of the cosine, so it has the same period before it repeats. Now, if we wanted to extend this, we would realize there's another asymptote at 5 pi over 2, and there would be another asymptote at negative pi over 2, and then we can just extend the pattern. Okay, so remember secant is 1 over the cosine of x. All right, let's graph the cosecant. Cosecant is the reciprocal of the sine. Oops, sin sine x. All right, so let's graph a little sine wave. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. I dash it. Okay, so notice that the range, or the max and the min is negative 1, the max is 1. The range, or the amplitude, or the amount, height between the graph is 2 units. Its range is negative 1 to 1. All right, now, but we're doing the reciprocal of it. So anywhere we see a 0 for the sine x, we know there's an asymptote for the cosine. So I'm going to, for the cosecant. So I'm going to dash in my asymptotes. That would include the y-axis. There's one at pi. And there's one at 2 pi. Okay, so now I'm going to graph this one as I've got a frowny face. I'm going to do a smiley. Flip over the curve. Run along your asymptotes. Same thing over here. Flip it over, run along your asymptotes. Sorry. And it does keep going on and on and on. Okay, cosecant is equal to 1 over the sine of x. And that's how we can type it in the calculator, which we'll do shortly. Okay, now, maybe we want to, well, I'll do that later. Moving to the cotangent. Okay, so if I think about the unit circle, I'm just going to do a quick sketch of, again, of what the key points are. I'm not drawing the circle. Negative 1, 0, and 0, negative 1. What is the cotangent at its x over y? So cotangent is 1 over 0 or undefined at 0. So this is an asymptote. Okay. The cotangent at pi over 2 would be x over y, so it's 0. And then it's undefined at pi. At 3 pi over 2, it's 0 again. And the cotangent is the reciprocal of the tangent. Now, the tangent went like this. So what do you think the cotangent might do? Go that way. Instead of going that way, it's going to go that way. Okay, it's going to flap. So it's going to be a twist passing through 0, 0 at pi over 2. This is another twist. And the period is pi. All right, and if we wanted to continue the graph, we back up pi units to the left. And we make another twist. This would be the bottom half. We good? All right, So you got to know where to graph those. You just need to know where the asymptotes are and where they hit 0. All right, those are the the 6 trigonometric functions, and I'm going to show you them in the grapher. Okay, so sine x, oops. Oh, I had hit the right button. Now I'm going to zoom 6. And I'm not going to see what I graphed. What's wrong? How do we have our x-axis labeled? It's not in degrees, is it? We have it all in radians. Okay? So you either have to change your mode to radians, but I probably wouldn't do that right now. I would hit zoom. I'll just show you another way to get it quick. Something we're working on right here. Trig. That's the one. So you hit zoom 7. Here we go. But you have to know all these values. They're not going to be labeled for you. Okay, you've got to know where the asymptotes are. You need to know where those key points are. All right, so there's your sine wave. Now, if you go back in y equals and put in the second line cosine x, graph it, you can see that it's really the same graph as the sine, except it's shifted. It's over pi over 2, actually. Or, yeah, pi over 2. Because when I teach you how to do equations for graphs that you see, you're going to learn how to write them. You can actually write a cosine or a sine for any of these waves. But I'm going to have to show you how to show it shifted. And yep. So I'm going to do that now. So I'm going to do the cosecant, which would be 1 divided by, what's the cosecant? The reciprocal of the sine. 1 divided by sine x. Give you that graph. Okay, and of course, if you want to do the secant, you do 1 divided by the cosine. And what really looks kind of cool is when you put in the sine and the cosine with them. You see how I taught you how to graph it that way using the reciprocal, so you can see all the things that we just did. So that's 4 of the graphs that we did. Very pretty. Let's see what happens if I do the other 2. I've literally seen kids doing this in class before they ever learned it. Like they've messed with these buttons. One divided by the tangent of x would get you the cotangent. Oh my goodness. Isn't that pretty? All right, well, there they all are together. No, we're not going to have to graph them all on one graph thing. No, thank you. Okay, so that's all we're doing new today. And now I'm going to take questions and help on homework.